In the previous video, I said that it was possible to use calculus to work out the location of these stationary points. But it's not easy. Let me show you what it looks like. So the function was y equals 2x squared plus 2 over x squared plus 2x minus 3. Now, this is a quotient. It's u over v. Now, the way I've written this should alert you. I'm going to use the quotient rule, not the product rule. And the reason is because this v is so complex that using the product rule is going to give you a mess of algebra you're not going to like. If you don't yet know the quotient rule, learn it quickly. Let me show you. U is the bit on top, 2x squared plus 2 over, that's u, so u dashed is 4x, and that's all. V is the bit on the bottom, x squared plus 2x minus 3. Now see, if this was the product rule, I'd have to go all that to the power of -1, and it's a mess. Trust me, I tried it. So I'm going to use the quotient rule instead, and if you don't know it, learn it. V dashed is the derivative of this, which is, it's 2x plus 2. And I don't have the -1 powers and chain rule and yeah. So the quotient rule says this. If y is the quotient u over v, then y dashed is v u dashed minus u v dashed. Whoops, my mistake, v dashed, I'm getting ahead of myself. V dashed all over v squared. And I remember this by going, I'm dividing by v squared, that's the thing on the bottom. So because I'm dividing by it, that's the one I'm going to subtract the derivative of. Why is it v squared on the bottom? Well, first of all, if you want a good algebra exercise, try proving this using the product rule. Just go uv where v is something else to the -1. Try proving this. But it comes about because this would have been to the -1 for the product rule. When I differentiate that, I'll get something to the -2. So this is the quotient rule, and I'm just going to use it. Put in what I know. V is here. X squared plus 2x minus 3. U dashed is 4x minus u 2x squared plus 2. V dashed 2x plus 2 all over v squared. Now, I'm not actually substituting this, and the reason is I have to find the stationary points. I'm going to find the stationary points where whatever's on top of this fraction is 0. So I actually don't care at all about the bottom of this fraction. So I'm just going to leave it always over v squared. Expand brackets. 4x cubed plus 2x squared minus 12x minus, expand the brackets, 4x cubed, that's nice, it'll go away, plus outsides 4x squared, insides plus 4x, lasts plus 4. And that's all over v squared. Sorry about the tilt there, it's just easier for me to draw the fraction line. Okay. I actually can simplify this in one go if I'm careful. 4x cubed minus 4x cubed will go away. 2x squared, that's not right. 2 times 4 is 8. Did you spot that mistake before I did? 8x squared, wrong line. 8x squared minus 4x squared leaves 4x squared. Minus 12x minus 4x is minus 16x. Take away 4. All over v squared. And I can simplify that. 4 x squared minus 4x plus, minus 1 all over v squared. Still don't care what's on the bottom. Okay, I did all that because I wanted stationary points. Stationary points are found when y dashed equals 0. And that happens, well, this can't be 0, so this must. 0 is x squared minus 4x minus 1. I'm looking for two numbers that add to give me negative 4 and multiply to give me negative 1. I am not going to find this quickly. If you like, you can use the quadratic formula. That will get you to the answer. I personally prefer to complete the square. It's x squared minus 2 times 2x, and then what do I have to add? A squared minus 2ab plus b squared. I need to add 2 squared. So subtract 2 squared and subtract the original 1. So all I've done is add 4, subtract 4. Why did I do that? Because this now is a square. It's x minus 2 squared. Minus 4 minus 1 is minus 5. Okay, rearrange. 5 is x minus 2 squared. Plus or minus root 5 is x minus 2. So x is 2 plus or minus root 5. Now, if I'm going to draw this on my graph, I'm going to need an approximate decimal value. Well, root 5 is between root 4 and root 9. It's actually only just more than root 4, so it's just a bit bigger than 2. So this is x is 2 plus or minus 2 and a little bit. 2 point something small, okay? Which is going to give me x is approximately negative point something small or 4 point something small. Now, I did say when I started this exercise that I wasn't going to finish it. And what I'm not going to do is plug these values, or particularly not these ones, root 2 plus root 5, 2 minus root 5, I'm not going to try plugging that back into here. It's just a mess. But you could in theory. All I'm going to do is this. I'm going to say just under 0. It's just here. It's actually not where it seems to be here. The maximum is actually here somewhere. And the minimum is just over 4. So the minimum point's about here, not quite where I drew it. So I'm not going to try substituting them back in to figure out the value. It's just an algebraic mess. But you could if you really had to. I think if this was actually a tech-free exam question, you would be given one that was easy to substitute. Preferably easier to differentiate, definitely easier to substitute.